although this lysis might occur in the body or outside the body. If it occurs outside the body, this is an artifact, and we're going to talk about it later. So, and the other causes are either the patient is not, the kidneys of the patient are not working well. Okay, you have a kidney here. He is not passing urine. He is not producing urine. And with this urine, as he is not producing urine, the potassium will not be excreted in the urine, so the potassium will stay inside the body. This is oliguric renal failure. Or the body is producing urine, but there is something preventing it from losing potassium. As a diuretic, diuretic will increase urine excretion, but the potassium will stay inside the body. This is a potassium-sparing diuretic. The other cause is adrenal insufficiency. In adrenal insufficiency, aldosterone will increase the sodium reabsorption, okay, and it will increase the potassium loss. But in adrenal insufficiency, there is no aldosterone, sodium will not be reabsorbed, and potassium will not be excreted, so potassium will stay inside the blood and to lead to hyperkalemia. So generally, those are the main causes of hyperkalemia. I'm going to just draw them so they look more easy. You have, this is a human body. Okay, I will try to draw a human body anyway. If this patient is taking supplemental potassium, if this patient have cannula here, or at least it looks like a cannula, and he have a drip here, and there is blood, and you are giving him the blood very fast, massively, you are giving blood massively to this patient. What will happen? This massive blood transfusion, all the blood will enter here in the body. If it's very massive, there will be increase in the concentration, increase in the RBCs inside, and the RBCs will undergo hemolysis, and the potassium inside of them will go out of to the circulation and lead to hyperkalemia. So massive blood transfusion can lead to hyperkalemia. The other thing, you are giving him another drip, but it contains potassium chloride. The patient might be on hypokalemia, so we are trying to fix it by giving potassium chloride. Okay, this will lead to hyperkalemia. Now, to the other causes. To other causes we have that we just mentioned. So we just added two causes here. Now I'm going to repeat the previous causes. Either the patient is not losing any urine, meaning oliguric renal failure, okay, oliguric renal failure, or the patient is passing urine, but is passing urine without potassium. Without potassium. Why is that? Because he is using a potassium-sparing diuretic. Or the patient is having everything okay, his kidneys is okay, but he does not have aldosterone. He does not have aldosterone, so there will be sodium reabsorption and potassium will not be excreted, and this is adrenal insufficiency. So just to review, either you are taking potassium in through a massive blood transfusion or through a potassium chloride, or you are not losing any potassium through the urine due to oliguric renal failure, or you are using a diuretic, but this diuretic is preventing your renal tubules from excretion of potassium, or you have adrenal insufficiency, you don't have aldosterone, so potassium will not be excreted in exchange to sodium reabsorption. The other thing is that you have the cells in your body which contain potassium, they undergo lysis, they die or anything like this, and potassium will be released into the circulation. Potassium will be released into circulation and will lead to hyperkalemia. This occurs in, for example, you have a patient on chemotherapy. He's receiving chemotherapy, and suddenly he goes into hyperkalemia. Why? Because the chemotherapy killed the cells of the cancerous cells, and these cancerous cells release potassium toward intracellular inside of them. Okay. Also in crush injury. Okay. Also in burns. And those all are causes of lysis, and yes, and even massive blood transfusion have the same theory. So those are the causes of hyperkalemia. Now there's something very important. For example, if a patient, you are taking blood from the patient for potassium, to measure the serum potassium, but you do a very tight tourniquet here, or your cannula is very small, okay, or you leave the blood after you take it, you leave it in the tube for a long time before it goes to the lab. What happens here? The cells will undergo hemolysis, and the potassium will be excreted inside the tube, and when the labs measure the potassium to be high. Or your short cannula or small cannula is very small, so that when RBC pass through it, it breaks, the RBCs break and release potassium, or this tourniquet break the RBCs and there will be a hyperkalemia. So this is an artifact. So those are the causes of hyperkalemia. The causes of hyperkalemia are present in this picture, and this is very helpful, so you can summarize them or at least understand how it happens. Now, so you take the serum, be aware of the artifact. You take the serum of potassium, it is high, and you want to, or it was an artifact, you are not wanting to do any serum potassium, you might do an ECG, an electrocardiography. In the electrocardiography, we will have, as we said, hyperkalemia. In the previous picture, hyperkalemia. Hyper means high, K is a potassium ion,